All right, folks, so listen, I will sort of go over the sort of the format for the exam. I sort of did this in the in-class section, but just want to go over the format of the exam, and then I'll take particular questions. So it does cover chapters 1, 2, and the very first part of 3. So in chapter 1, we had several topics. We had units and unit conversions. I think you had 1 or 2 questions like that. We had dimensional analysis. You have a couple of questions on that. You have approximations. I think you just have 1 question, maybe 2 on approximations. We had standards. What are the standards of measurement and what makes a good standard? We also had in chapter 1 our trig. Is that it for chapter 1? Am I missing anything? I think that's it. We'll come back if I remember. And in chapter 2, we had kinematics. And I sort of break this into a couple different things. We have, calculations. That's sort of our word problems that we've been doing, where you have something traveling at a certain speed, you have to calculate the time or acceleration or whatever. That will include, for example, free fall problems, and you will have a free fall problem, maybe more than one. And then conceptual. Those come largely either from the notes or from those concept tests. So basic knowledge about what is kinematics, what is average speed, what is velocity, all that jazz. Graphing, which is still kinematics, but in my mind I sort of separate it a little bit. And then we'll have qualitative. That is where you have, your x versus t, and I ask you to describe that graph or ask you to translate it into a v versus t. And then quantitative. That is where you have to calculate the slope or area in order to provide some physical value. What is the velocity? What is the acceleration? Kinematics, graphing, that's it. Yeah, that's it. Okay? So we can go through some of the old tests, or we can just look at some old topics that you might want to sort of review. Are there particular topics that you want me to just review? Yeah, Bree?
Chapter 2's concept questions.
Mm-hmm.
I'm just having a hard time, understanding the concepts,
Right.
how it works.
You mean for the graphing or for the kinematics?
Let me see. Okay, this question in particular, if the velocity of a car is non-zero, can the acceleration of the car be 0?
Okay. Let me show you guys first before I go on, and then we'll address some of those. But make sure that y'all are aware of the resources that we have on the website. So if you go on the website, if you click on this concept test, then you can download these. Have y'all seen this before? Yeah, so if you download, say, for example, chapter 2, then you can get the questions and the answers. So let's see, like that question, for example. I had another student ask me a similar question earlier in the day. So let's address it for just a moment. Remember what number it was? This one. Okay, so if the velocity of a car is non-zero, can the acceleration of a car be 0? So that's saying if this car is traveling along at a constant speed, can the acceleration be 0? Can it travel at a constant speed and not accelerate, not change speed? Then yeah, the answer is yes. So it can do that. There's another question that a student had a lot of trouble with recently, this morning, he came to ask me about, where you throw something up in the air, and it asks what is the velocity and the acceleration at the top. And the answer was that the velocity, of course, is 0. We've mentioned that before. But then also that the acceleration, is the acceleration 0 or is it non-zero? Well, it's not moving, right, because the speed goes to 0 at the top. But what is the acceleration? Is it non-zero or is it 0? it's non-zero, right? It's always equal to -10 because it's under the free fall acceleration. So what I would do with these is I would just print them out with the questions and the answers, or maybe just write the answers on your page and sort of go through and quiz yourself on them. Are there other questions from here? These are good questions, by the way, to practice, because some of your conceptual questions on the test will come from this.
I just didn't understand, like, it was 215C with the rubber balls where you had, like, the discontinuity with, because it was bouncing on the ground and coming back up.
Mm-hmm.
Like, I understand the other one.
This one? Oh, no, that's not it.
The one.
Yeah. All right, so you do need to be able to take a physical scenario and produce either the position or the velocity versus time graph. So let me go back to the blank page here. So in this case, I had a bouncy ball. I drop it. It goes down, and then it bounces back up again and comes back up to where you were. And you want to be able to draw the v versus t for this graph. You will need to do this, to take some physical scenario and produce either the v versus t or the x versus t graph for that. So think about the velocity versus time graph. Well, the first thing you want to ask yourself is right here, is the velocity positive or negative, and is it big or small? What is it, positive or negative here? It's negative, and is it big or small? It's small, right? It's initially 0, and in the negative direction, and then it gets bigger. So since you know it's negative and that you know it's small, it's going to start right here. That's in the fourth quadrant. It's a small value. And you also know that it's going to get bigger. So it's going to look like that. So I have a negative small velocity. And down here I have a negative big velocity. So you want to be able to ask yourself these questions about the motion and then be able to translate it onto a graph. You'll be tested on this. There will be some questions like this. And then, over here, is it positive or negative? Well, it's positive. It's going up. And is it big or small, the velocity? It's big, right? It's going fast. So a positive big velocity. And so that means that I'm going to be here. And then actually it's going to get smaller because up here I have a positive small velocity. And so my v versus t graph will look like this. Can you take this graph and produce an x versus t graph, or a y versus t graph? Can you do that? That's a little trickier, right? So, but you do need to know how to do that, because I'll provide you with one graph and you'll have to go from one to the other. But what about the y versus t graph? Okay, well first we want to look at the slope. Let's just sort of take this part right here. I know that my y versus t graph has to have a negative slope, and it has to be small. So I have to have a negative small slope. So it's going to be sort of like this. Negative small slope, and the slope is going to get bigger. Like that. So for this portion over here, my graph is going to look like this. I can think about my tangent lines. See, negative small slope, negative big slope. Negative small value, negative big value. Do you know this fully, or are you confused? You look like you're either bored or you're confused. Are you bored or confused? Or just processing? Processing. Okay. So what about on the next section of the graph? Well, this graph tells me the value of a slope. Positive big slope, positive small slope. Positive big, positive small. If you've done this lab, you know what it looks like, right? You don't know what it looks like? Have y'all done the lab yet? Not everybody's gotten to it. It looks sort of funky.
The basketball one?
Right. The bounce pass. So here, positive big slope, positive small slope. So this graph describes the same situation as this graph. Okay? You need to be able to go back and forth between these. The slope, the value for the slope is represented on the v versus t graph, and vice versa. the value for the v versus t gives the slope, whether it's positive or negative or big or small. You need to be able to, yeah, tell me your name again.
Mackenzie.
Mackenzie.
Okay, I understand the up and down, whether it's negative or positive velocity, but what happens if it's like east or west?
Okay, well, if it's east or west, I don't use any cardinal directions, by the way, on the exam.
Okay.
I just use positive and negative. So if we're looking at our coordinate system, this is positive, this is
all the
negative.
same.
Yeah. So there's no cardinal directions at all. Okay, we'll see some cardinal directions maybe on the next exam. We'll see. But we'll deal with that when we come to it. Does that answer your question, Mackenzie? Anything else? Any other questions? I wanted to show you one other thing, but any other questions?
So we don't have vectors.
No, you have vectors. No cardinal directions. No north, south, east, west. Yeah, you had 3 questions on vectors. Did I write that on the previous slide?
I didn't. No, you didn't.
No, I didn't. Let me go back to that. So you also have chapter 3a. That's what I was forgetting. That I have vectors. When I say vectors, I mean graphical addition or subtraction. That's where I give you 2 arrows like this, and I ask you to add or subtract them. And then also numerical. That is where I give you 2 vectors, one on axis, one either on the x or y axis, and one off axis. And you have to give me the sum or the difference. I ask you for the sum. Okay? Make sure you can do those. And then there's a third question similar to some of the concept test questions. Okay?
Yeah, I need to skip ahead, but the other day in class you had an example, it was like b minus a, so whatever vector comes first, that's the one that we...
That's right. Let's do that one, okay? Like imagine that this is b and this is a, and I want to know what is b minus a. Then first I would draw b, whatever comes first in the difference or the sum I put first. And then I draw minus a. And so if this is b, minus a is just a flipped. You just put the tip on the other end. And then the sum of b minus a, which is, the difference of b and a, will look like this. I always start at the beginning of the first vector and end at the end of the second vector. That should be a gimme problem for y'all. I want y'all to get that definitely so, okay? All right. Let me show you one more thing, because graphing I think is difficult, and there are like 6 to 8 problems on graphing that have to do with calculations or graphical. Yeah.
I had a problem on the OpenStax assignment, and there was, I think we went over it in class again, but there was like a green line, and I remember there was a point at like 6.2, and then it was like the velocity at 12 meters per second.
Uh-huh. Yeah, there was a v versus t graph. I think it was the runner velocity. Looked like that.
Yes,
Oh, I had it there. Yeah, so on this one it asks for the average acceleration and also for the distance. You want to work through one like this? I'll just make up some numbers here. I'll have this be 0, 0. This will be 3, 6, 9, 12. Now let's do 2, 4, 6. These are in meters per second, and these are in seconds. All right, so I could ask you a couple things. I could ask you, what is the average acceleration? I could ask you, what is the instantaneous acceleration? I could ask you 3 things, actually. And I could ask you, what is the distance that they travel? And each of them require, in fact, I will ask you these questions. Each of them, each of them require a different approach. So if I ask you for the average acceleration, I would give you a time, say between t equal 2 and t equal 6 seconds, for example. In that case, you would say average acceleration is delta v over delta t between t equal 2 and t equals 6 seconds. So that's going to be Vf minus Vi, 4 minus 2. I got it from here and here, divided by delta t, which is 6 and 2. 6 minus 2 seconds. And so that's 2 over 4 meters per second squared. That's one way, or one thing that I could ask you. I like to think of this, by the way, I like to draw a line in between them. And then it helps me to think about, I'm just finding the slope of that line when I'm doing average acceleration. I could also ask you, what is the instantaneous acceleration? In order to do that, I find the slope at a particular point. Like, let's say I want to know the instantaneous acceleration at t equal 2 seconds. At t equal 2 seconds, that's right here. Notice I don't give you a range of time, I just give you an instant in time. In order to do that, I would just find the slope of this line. The rise is 4, the run is 3, and so the instantaneous acceleration is rise over run, which is 4 over 3. Sometimes I might give you a v versus t graph that's curved, and I might ask you for the acceleration at a particular point, say right here. It's not a straight line, but you can sort of fit a line at that point, and then you would find the slope of that line. Okay? Now the third part is to find the distance. Now let's say I wanted you to find the distance from 0 to 12 seconds. How far did this person travel from 0 to 12 seconds? What you do there is you find the area. I find the area here, 1/2 base times height. It's a triangle, right? That's a half of 3 times 4, which is equal to 6 meters. Notice the units work out as velocity times time, meters per second times seconds, which is meters. And then I also find the area of this part, which is length times width. 3 to 12, that's 9, times 0 to 4 is 4, is 36 meters. And then I add those up and I get 42 meters. So I can, and in fact I will, ask you, I think I asked you all 3 of these questions. Find the average acceleration, find the instantaneous acceleration at a particular point, and to find the distance that he travels. You should expect those questions. You expect them? They will be on the test. Okay. By the way, what's the acceleration here? The instantaneous acceleration. 0. Right. So like if you see a flat line, you shouldn't have to think about it. Say, oh, that's 0 because it's a flat line. If you're looking at a v versus t graph, you should also expect to see some position versus time graphs. And I ask you for the sign of the acceleration. We've seen some of those. Can I move on from this one? Is this okay? Here's 3 questions from the test. You already know the 3 vector questions. You know, some of the OpenStax questions are going to be on there. So you already know like a third of the test. Right? Awesome. I want everybody to do well. I want an 80% average. That's really what I'd love to have. I give you an x versus t. I want you to be able to tell me, is this positive, negative, or 0 acceleration? And you got to do it quick, okay? And so when you look at this graph, what you want to ask yourself is, what is the sign of the slope? And is the speed increasing or decreasing? The speed here is decreasing, so I know that the acceleration is opposite the velocity. So whatever the velocity is, the acceleration is opposite that. And the velocity is positive or negative? Positive. So this has a negative acceleration. All right, let me write that down. So what I ask myself is speed going up or down? Is decreasing? Goodness, bless you. Is the velocity positive or negative? In this case, it's positive. So the acceleration then has to be negative. Because if it's slowing down, the acceleration and the velocity are in opposite directions. And you should be able to do that for the other. There are 3 scenarios that you can have for this. Also, remember that if I have x versus t, and it looks like this is a positive velocity. If I have x versus t, it looks like this is a negative velocity, just because the slope is negative. Yeah. Your name?
Kylie.
Tyler.
the first one, can you explain like how you know that the speed is decreasing?
Sure, because I look at the slope. I look at the slope of that graph. I know that the slope gives the velocity. So this has a big slope, smaller slope, smaller slope. That slope is decreasing? That's a great question.
Okay. I just got it confused from like the other way because I know like it goes. Yeah. Okay. Sorry.
Yeah, let's practice. So tell me, on this one, x versus t, positive or negative acceleration? Is the speed increasing or decreasing? It's decreasing. It starts out big, small. Is it positive or negative? Negative. And the acceleration then is positive. That's what you want. You want about 10 seconds turnaround on doing that in your head, okay? All right, awesome. Okay? What else?
Can you go over the vector type questions where it's like numbers? Like
Yep. No, I can make up one. Is that okay? But I'll make up one that's like on the test. So let's say that I'll give you two vectors. Let's say A and B. A is 3 units along the plus y-axis. Like your language is going to look very, very similar. B is 2 units at, I don't know, 40 degrees from the plus x-axis.
So you're not going to take north.
No cardinal directions. You'll not have any cardinal directions on the test. That makes your life a little easier, right? Yeah. When you do the vector lab, in the lab, you'll do cardinal directions. I'm not too worried about it. If you know north from south, that's great. Never eat soggy waffles, right? Isn't that what you're supposed to do? You want to continue on with this? Is that okay? All right, so what you want to do, your first step, is find out what is AX, AY, what is BX, BY. This problem should take you a couple of minutes to do, okay? But if you're sitting around twiddling your thumbs, it'll take you longer. So you really need to know how to do it right from the get-go. So AX is 0. AY is 3. How do I know that? Well, think about our vector. A is 3 units along the y-axis. So it has no x component. BX is 2 cosine 40. BY is 2 sine 40. Now be careful because in this case I gave you B is in this direction. But if B was, for example, over here, if it was 40 degrees from the negative x-axis, what would be BX? Would it be positive or negative? It would be negative, right? So I always find it very, very helpful to draw a picture. In fact, let's do that here. I'm going to change this just a little bit. I'm going to change this 40 degrees from the negative x-axis, just so we illustrate that and get rid of that. And so now BX is going to be negative 2 cosine 40. You'll see what I've done? I find that it's nice to draw a picture because then it helps you to see, oh, well, the x component of this one is on this axis. And so I need to make it negative. So take those few extra seconds to draw yourself a picture. And then we want to calculate this. This is 2 cosine 40. I get 1.5.
Before you go further, like I know we're just like supposed to look at it and see that, but if you don't just look at it and see 140 and all that, if we wanted to write it out, we're just basically you just already solved for x and solved for y, correct? Like if you were to actually set it up, it would be y over 40 or y over
Oh, like if you started with SOHCAHTOA?
Yeah, like if you were to say cosine 40 for y over 2, you just already solved for y.
Right. So cosine theta, this is x, this is y, is equal to, this is bx, by, this is b. Cosine theta then is bx over b. So bx then is equal to b cosine theta. And in a similar way, by is b sine theta. But I urge you to not have to go through that step. I urge
Always
you.
going to be cosine.
For this class, yeah, it depends. Like if you're measuring your angle over here, then it's gonna be it'll be different. It'll switch. But we'll see that in chapter 4. So let's not worry about that right now in a second. So I urge you to just memorize these or internalize them. And I remember because it's alphabetical. X, Y, C, S. That helps you. That's highlight, right?
Yeah, so we're not gonna have any of the like triangles right there and have to figure it out that way. Like,
You will have a trig problem that's separate, where you have to, I give you a triangle and you have to find out what is the angle or what is the length of the hypotenuse. Okay? So here, now that I have bx, by, ax, ay, I find, this is my first step. My second step is do ax plus bx. That's minus 1.5. ay plus by. That's 4.3. And then if I want to know the magnitude, I say the square root of 1.5 squared. It's actually negative 1.5 squared plus 4.3 squared. And that'll give me the magnitude. If I want to know the angle theta, I say the inverse tan of 4.3 over 1.5. And that's 70 what? Be careful with that negative sign. I'm just going to write 70.8 degrees. But then I'm going to remember where is my, I'll draw my picture. I know this seems overwhelming, but as you practice with this, you'll get it. Trust me, I've seen students do this before. I have my AX over here, my AY over here, and so my angle theta looks like that. And so it's 70.8 above the negative X axis.
So you don't put the negative in the
No. Because sometimes your calculator is smart, and it will know, like if you put a negative 1.5, it'll say, oh, this angle is in the second quadrant. And actually negative 70.8, that's not even the right answer. So obviously your calculator is not smart enough. It doesn't realize that it's in the second quadrant. It thinks it's in the fourth quadrant, because that would be 70.8. So I'll leave out the negative signs, and then just get the angle, doing the opposite over adjacent, y over x, and then draw a picture and ask yourself, what quadrant am I in? So you'll have a problem like this, okay? 2 or 3 minutes, try to time yourself on it. I don't want to rush y'all. Like the test is sort of this curious balance between go quickly as you can, but then be very careful as you go along, because if you make mistakes along the way, they'll come out, you know. I know it seems impossible. It's not. You can't do well. Okay? It's not impossible. Does it seem impossible? No? It seems impossible? It's not. Y'all are super smart. I know y'all can do this. You wouldn't be here if you weren't capable. Yeah.
A and B is always going from 0.
Yeah. So remember, with our vectors, we can move them around however we want. So like, I can draw vector A here, or I can draw it over here. Or I can draw it over here, as long as I keep the length and the direction the same. Okay? So I usually draw my vectors from the origin, except over here, I translated my vector over here to create this nice triangle, so I can see where that vector theta goes. All right. What else, y'all?
But if we would have left it on the positive, what did you do in order to change?
Well, if it was positive from the positive x-axis, how would it change? This would be positive. So this would be positive.
Would it just be flipped?
Yeah, that would be positive. Yeah, it would still be positive because we weren't subtracting numbers here. So that every... That's right, Akira. Yeah. Now, if AX was non-zero, it would be a little different, because then we would have been subtracting 2 numbers here, right? But yeah, I don't remember. I think I have a positive. Like I think that I don't remember. I don't want to tell you wrong. So be prepared for that. Draw pictures. Oops.
I'm not gonna ask a question like assuming this one, right?
No, that's projectile motion. So listen, on the exam ones, sometimes on those exam ones, they were scheduled a little later, or we just moved a little faster. We get to projectile motion. So if you see anything where something is launched at a certain angle, that's not on this test. That is the second part of chapter 3. Tyler?
One like this, with the, like, someone like jumping off the diving
Uh-huh.
board and,
Listen, you're not going to see one that's like that on the test, but you'll definitely see some that are parts of that on the test. You follow what I'm saying? So in that problem, you had one on OpenStax too. You have something that goes up and comes down. Let's do this problem first, because that's a very important problem. You will see it on the test. It's important because we use it in chapter 3 when we do projectile motion. If you master this problem, and once you master it, it's not that hard. It's just when you haven't mastered it, it's hard. Once you master it, projectile motion becomes fairly straightforward. So let's just do this problem. When I have something that goes up and comes back down again, there are a couple things that I want to find. I want to find how high does it go. I want to find how long is it in the air. And that's it, really. So, yeah, I would give you the velocity. So let's say that it goes up with an initial velocity equal to 20 meters per second. I want to know how high it goes and how long does it take to return back to your hand, the total time. So a couple things to recognize is that the velocity at the top is equal to 0. Now when I throw this thing up in the air, the velocity stops. It stops up at the top. Just for a moment, but it stops. And then also, I need to recognize that t up equals t down. All right? So what if I asked you how long, what is the total time that it's in the air? Then you would take your kinematics equations, v equals v naught plus at. Realize that v top is equal to 0. So I have 0 equals 20 meters per second plus negative 10. That's my acceleration in the y direction. That's only true if I'm traveling in the y direction. If I'm traveling in the x direction, it's not necessarily 10. It is whatever it is, times t top. And so t top equals 2. That means it takes 2 seconds to go up and 2 seconds to come down. So the total time is equal to 4 seconds. That's one possible problem. The other possible problem is I could ask you what is y, and y then is v naught t plus 1/2 at squared. And here you need to be careful because we have 2 times floating around. Make sure you use the right time. So that's going to be 20 meters per second. What time do I use, 2 or 4? Right, 2 seconds. 1/2 minus 10. 2 seconds squared. That's 40 minus 20. It's 20 meters. And so this thing goes up a distance of 20 meters. Those are 2 possible questions that I could ask you. All right? Yeah.
Why is it from the top to the bottom?
Right. From the y, the 20 meters, is from here up to here. We're always assuming that our beginning point is y equals 0. That's sort of always assumed that our initial point of time is at y equals 0. If you're an MCAT, how many do you have 3 minutes? No 3 minutes? Okay, well, if you're on the MCAT, sometimes that's not true. That your y naught will shift around, but we're not going to deal with that. Okay? Now, the second part of the problem is where this thing is traveling downwards at negative 20 meters per second. And say it drops a certain distance, say, I don't know, 40 meters. And then I want to know how long does it take to drop down that distance. Or I could give you the time and ask you what is the distance. I wouldn't ask you the to find the time. That requires you to use the quadratic. But I could ask you to find the distance, like give you the time and ask you to find the distance. Can do that? Let me show you. Say y equals v naught t plus 1/2 at squared. Let's say that instead of giving you the distance, I say that it takes, I don't know, 4 seconds to drop. Then you would say negative 20 times 4. Negative 20, that's that initial velocity at that point. T is 4 plus 1/2 of negative 10 times 4 squared. It's negative 80. 5 times 20, 100. Oh, no, it's not 5 times 20. It's 5 times 16 minus 80 equals minus 160 meters. So that distance from the top of the cliff down to here is 160 meters. It takes 4 seconds to fall. It's 160 meters.
So, I have a question. On one of the exam questions, it says you drop a ball from 12 meters above the floor. How long does it take the ball to hit the ground? You're not asking that?
Yeah, I could ask it.
Okay.
That one's different. So I ask a question. I drop a ball from 12 meters above the ground. How long does it take to reach the ground? The reason it's different is because v naught is equal to 0. The reason I wouldn't ask you in the previous problem is because y is v naught t plus 1/2 at squared. In the previous problem, v naught was not 0. And so that term doesn't go away, and you have to use the quadratic formula. And I don't want you to use the quadratic formula because it's tedious, and you know how to do it anyway. So in this problem, if I wanted to know, what was it, the time I was asking for? You would say 12. Actually, you would say negative 12. I'll show you why that is in just a second. Equals 1/2 of negative 10 times t squared. The reason you use negative 12 is because this is our origin, and it is y equals 0. So down here, y is equal to negative 12. This is y naught. So it's based on our frame of reference, our coordinate system. But if you forget the negative here, you're going to run into a problem because you'll say, well, this is negative. And then when you get a little bit further, you'll say, oh, of course, this is negative. I can't take the square root of a negative. So I'm not too worried about that. So this works out to be 12 over 5. The square root of that is t, whatever that is, 1 point something seconds. Okay?
Do you mind, like rearranging the 12 equals, negative 12 equals?
Absolutely. Yeah, so I sort of zoomed through the algebra, but I understand for some of y'all, for most of y'all, in fact, that you can't really do that. So let's take this, for example. Minus 12. I'm going to go and make that half negative 5 t squared. I divide both sides by negative 5. That cancels out there and there, makes this positive. And so I get 12 over 5 equals t squared. And then I square root both sides in order to get t is the root of 12 over 5. That's the easiest way. There are other ways you can think about cross multiplying and stuff, but I think that's the easiest way. Anything you do to one side of the equation, you have to do to the other. And you want to isolate your variable to one side. Okay? I have about 5 to 10 more minutes, so I have another meeting at 3. But what else do I want to do? Vectors, kinematics,
Quick question.
dimensional analysis. Rebecca?
Okay, on mine, the answer key to this one in the video does not align, so it's real confusing.
I'm sorry. I remember that. I don't have the answer key that aligns with the video. I just scrambled the answers at some point. I'm sorry for that. But the answers themselves should.
Are correct, the numbers itself.
It should. It's pretty old, that stuff. How old is it?
2010.
Yeah. Sorry, I wish I had it still. I would replace it, but I do not. What else, ladies? One thing we haven't done is we haven't done dimensional analysis. Y'all okay with that?